we'll find the derivative of secant theta. To do this, we will have to look at secant theta for what it is, which is defined to be 1 over cosine theta. And 1 over cosine theta is like saying cosine theta raised to the negative first power. And this does not mean inverse of cosine theta. This means cosine theta raised to the negative first power. And now we're taking the derivative of power function, so we can use the power rule. So firstly, I'll take this negative 1, bring it to the front as multiple. So we have a negative 1 times, input stays the same, so we still have the cosine theta right here. And now we have to subtract 1 from the power, so this will become to the negative 2 power. And then we can't forget the chain rule, multiplied by the derivative of the inside function. Derivative of cosine theta is negative sine of theta. Let's clean this up a little bit. The negatives cancel out, because negative times a negative is positive. So now we have sine theta from right here. And when you have cosine theta to the negative 2 power, that's like saying 1 over cosine squared of theta. And we found our derivative for secant theta. But I'm going to rewrite this a little bit to see how we usually write the derivative for secant of theta. So I'm going to look at this as 1 over cosine theta times sine theta over cosine theta. 1 over cosine theta is secant theta, and sine theta over cosine theta is tangent theta. And this is how we usually write our derivative for secant of theta.